Hello guys, welcome back to my channel. Today we're going to solve this Leetcode question, which is minimum number of steps to make two strings anagram. Okay, let's go through the question. You are given two strings the same length s and t. In one step, you can choose any character of t and replace it with another character. Return the minimum number of steps to convert the string t into as an anagram of string s. An anagram of a string is a string that contains the same characters with a different ordering. This is the most important thing we need to take care of. Uh, let's say, what is an anagram? You know, I tried to explain more easily. Suppose we have two strings. Suppose we have two strings. Two strings are called anagram of each other. If by rearranging the characters of one string, we can produce another string. I'll explain you with an example. Let's say we have a string called A, B, C, and we have another string called C, B, A. These two are called anagrams of each other because I can rearrange this string to produce this string, right? I can keep my A at the first place, I can keep my B at the second place, I can keep my C. I'm able to produce this string with the help of by rearranging the characters of this string. So these two are called anagrams. Let's take another example. ABC and another string is BCA. These two are also called anagrams. Now let's say we have something called ABC and suppose we have ABB. These two are not called anagrams because I cannot produce this string with the help of this string. The first two characters are getting matched, but the third character is not matching with the third character. What if I have something like ABB and I have AAB? These are also not anagrams because I cannot produce this string from this string, right? So I hope you got an idea of what an anagram is. Now, by getting the idea of anagram, let's dive into the question right now. Now, in the question, what we are given is we are given two strings. One is S and the other one is T, which are of the same length. Both the strings are of the same length. And we need to convert the string T. Basically, we are given two strings and we need to convert the string T into the as string S, as an anagram of string S. No, we need to convert the string T as an anagram of string S. And as an anagram, the order doesn't matter, but all the characters in the string S present in the string T. That's what an anagram is, right? And at each step, by one step, we can take any character and can replace it with any other character. Suppose, if we are converting this string into this string, we can at any point we can take one character and we can convert this character into A, B, or C until Z. We can convert any character into any other character, right? And we need to make sure that we are taking the minimum steps possible. Uh, let's try to understand the question by using an example. Suppose we are given two strings. S is B A B and our T is A B A. Now what I need to do is I need to convert this string as an anagram of this string, right? Now what I can do is, first I'll come to this character and I see that this character and this character are not matching. So what I'll do is I'll convert this as B, right? Then I'll come here. I see that B and A are not matching. So I will convert this B as A, right? We can convert into any character. We can make this as Z as well. But there's no point in making this as Z, right? We need to make them as both of them as anagrams. So I'm making this as A. And I'll come here and I can make this is B and this is A. I can make this as B, right? So in this process, I'm taking three steps, right? Um, I'm replacing three characters. But is this the what they call? Is this the correct solution? No, it's not, because we have to do it in minimum number of steps, right? We can do it in minimum number of steps by now look at this. When you come to A, you see that A is already present, right? So you will not convert this into B, right? Then you will come to B and you see that B is already present. So you will not convert this into any other character. Then you'll come to A and you see that there is no other A. This A already got matched. This B already got matched. All you are left with is one B. So you can there is no A in the string, right? So you need to convert this A into B in order to make these two as anagrams, right? So I have converted this string into an anagram of this string within one step. So this is the optimized answer. So this is the answer. Now let's analyze how we can solve this question. Uh, all we need to do is, we just need to map the characters, right? You know, suppose we have B, A, B, and here we have A, B, A. If you look at these two carefully, I'm matching this A with this B with this B, and I see that these two characters are not matching. So I can convert this character into B, and I can make this as an anagram of this thing. So my answer is 1, right? So this is the minimum number of steps. Let's take another example and try to solve it. It is, I'll write down this thing and I'll come back. Okay, now let's look at this example. Let's look at this example. I wrote down both the strings in a vertical way. Let's try to match the characters. Suppose this is the string S, this is the string S, and this is the string T. We need to convert this as this, right? So what I'll do is I'll just traverse through this string and I'll match the characters. I see that M is already present here, so I'm matching this to this, and A is also present. I'm matching this to this. N is also present. G is also present. A is also present. This A is, I'm sorry, this is an R, right? This A is also present. This R is also present. So since all the characters are already present in this string, so our answer is 0, right? Our answer is 0. Let's try to take another example to get more clear idea. Now let's take this example and let's try to solve it. Now, I wrote down these two strings in a vertical way. This is the string S and this is the string T. Now I need to convert this string into this string. Now what I'll do is I have P. Is P, can I match P with any of the character? No, right? So let's leave it as it is. I'll come to R and I see that I cannot match this R with any of the character. Let's leave it. Then I'll come to A, I cannot match this as well. Then I'll come to C, I see that I can match this thing with this thing. And then I come to T, I can match this. Then I come to I cannot match this because there is no I here. Then I come to C, can I match this with this character? No, I cannot, because this character already got, mapped with this character. So there is no point in mapping it again. So I cannot map it. Then I came to E, I can map it with this E or this E or this E, right? So for simplicity's sake, I'm just mapping it with this A. Now, if you look at this, what I can do is I can convert P to L, right? I can convert P to L. I can convert R to E. I can convert A to E. I can convert I to O. I can convert C to D. Because in one step, I can convert any character into any other character, as mentioned in the question. So, if you look at this, I'm converting 5 characters. So my answer is 5. Look at this. My answer is 5. So, how are we going to solve this question? Means, if you observe carefully, here we can use hash map, right? Here we can use hash map. What I'll do is, suppose, wait. Now let's try to think how we can solve this problem. You know, if you observe carefully, we can use hash map right here. What I'll do is, I'll I'll do the same exact thing, the mapping thing that we have done, 1 minute before. That the same thing that we are going to do here, but in order to map that, we need to use a hash map. What I'll do is, I'll just traverse through this array and create a hash map. So L is appearing one time, and I see that E is appearing 1, 2, 3 times, and T is appearing one time, and C is appearing one time, O is appearing one time, and D is appearing one time. Now what I'll do is, after creating a hash map for the first string, then I'll traverse to the second string, and I'll map each character with the characters which are present in this. Now I'll come here and I see that P is not present here, right? So I need to replace this character. So my count becomes 1. Initially my count is 0. Initially my count is 0. When I'm not able to map a character, I'll increase my count so that uh, you know I need to it indicates that I need to replace my character. So I'll come to R and I see that R is not present in this hash map. So my count becomes 2. Then I'll come to A. I cannot see A here. So my count becomes 3. Then I'll come to C and I see that I can map this C with this C, right? I can map this C with this thing. So when I map this character, I'll reduce the count of C. So the number of C's remaining becomes 0. Then I'll come to T. I see that I can map this T with this T. So the count of T will also become 0. Then I'll come to I. I see that there is no I in the hash map. So my count becomes 4. Then I'll come to C. I see that the count of C is 0, right? So I cannot map. I cannot map, right? So my count becomes 5. Then I'll come to E and I see that I can map my E to this E. So the count of E becomes 2. I have successfully mapped this E. So at the end of the traversal, my answer is 5, right? So this is my answer. So this is how we are going to solve this question. Let's try to implement the same thing by using this example. I'll come back after creating the hash map. Now this is the string S and this is the string T. Now I have created a hash map for this string. Now I'll traverse through this hash map and I'll try to map these things with these things. When there is a mismatch, I'll increase my count. Initially my count is 0. When there is a mismatch, I'll increase my count. Now I'll come to M and I see that I can map this M with this M, right? So my count becomes 0. Then I'll come to A and I see that there are 3 A's. I can map with one of the A and my count becomes 2. Then I'll come to N. I can map with this N and my count becomes 0. Right? Then I'll come to G and my count of G becomes 0. I have mapped this G and then I'll come to A. I have 2 A's remaining. So I'll map with one of the A and my number of remaining A's becomes 1. Then I'll come to A and I'll map this A with this thing and my count becomes 0. Then I'll come to R and I'll map this with this R and my count becomes 0. At the end, after traversing the entire array, our count remains 0, right? So this is our answer. So this is how we are going to solve the question. So let's try to look at the code. So this is our code. In this, I'm just creating a hash map. I'm just initializing creating an object of a hash map, and here from the string s, I'm creating a hash map. I'm just creating a hash map. Initially, I said the my count will be 0, and look at this. I'm just traversing through the string t, and I'm checking if my map is if my map does not contain the character, then I'll increase my count as I have mentioned here. When the character is not present in the hash map, I'll just increase my count, right? I'll just increase my count. And when there is a single character and I have mapped the character, I'll just remove it from the map. Instead of making it 0, I'm just removing the character. That's it. And if the frequency of the character is more than 1, I'll just reduce the frequency. I'm just reducing the frequency, right? Here when it is 3, I'm reducing it to 2, then to 1, then to 0, right? The same thing I'm doing here. And at the end, I'm just returning the count. That's it. If I submit it, it will, yes, it's getting accepted as I have already submitted it. So that's it, guys. Thank you for watching the video. And if you find the video helpful, then go ahead and hit that like button. Thank you.